Welcome back, guys. This time let's go a little bit over the ideal gas laws. The ideal gas law can be summarized with the equation PV equals nRT, where P is pressure in atms, V is volume in liters, N is the number of moles of gas, and T is the temperature in degrees Kelvin. Remember that regardless of the units given to you in the problem, you must change them to the units set in the definition. The reason for this is the gas constant R, which is 0.08206, atm times liters divided by moles times Kelvin. When solving ideal gas problems, R will always be 0.08206. Let's do a couple of problems so you can see how this equation is used. How many moles of oxygen gas are present at 32 degrees Celsius with a pressure of 672 torr and a volume of 24.1 milliliters? First of all, write down what you know and convert to the correct units. 672 torr equals 0.884 atms. Also, 24.1 milliliters equals 0.0241 liters. Finally, convert the temperature from degrees Celsius to degrees Kelvin, which is 305.15 degrees Kelvin. Now, rearrange the ideal gas equation to solve for the unknown. Number of moles equals pressure and volume divided by gas constant times temperature. In other words, 0.884 atm times 0.0241 liters divided by 0.08206 times 305.15 degrees Kelvin equals 8.51 times 10 to the negative 4 moles of oxygen. Let's do another problem. At what temperature in degrees Celsius will 5.5 moles of neon gas occupy 532.03 milliliters at 1.59 atms? Once again, write down what you know. Our pressure is 1.59 atms. Our milliliters must be converted to liters. In this case, it's 0.53203 liters. The number of moles is 5.5. We can rearrange the ideal gas equation to solve for the unknown. Temperature equals pressure times volume divided by number of moles and the gas constant, which means that 1.59 atm times 0.53203 liters divided by 5.5 moles times 0.08206 atm times liters divided by moles times Kelvin equals 1.9 degrees Kelvin. As you may notice, this problem did not ask us what the temperature was in degrees Kelvin. It's asking us what the temperature is in degrees Celsius. So you must subtract 273.15 degrees Kelvin for a total of 270 degrees Celsius. Another use of PV equals nRT is to solve gas density, mass, and molar mass problems. Well, keep in mind that the density of gases is defined as grams per liter, not grams per milliliters, but grams per liter. Additionally, remember that moles is defined as mass divided by molar mass. How does this help us? Let's take a look at a couple of problems to see how it can be used. Calculate the volume occupied by 736 grams of bromate, which is a molar mass of 127.9 at 1.06 times 10 to the negative 2 milliliters of mercury and 375 degrees Celsius. You may notice that the number of moles of this gas is missing. However, since we have mass and molar mass, we can calculate the number of moles present or simply place the ratio instead of the number of moles in the equation. Once again, write down what you know and convert to the correct units. Volume equals mass over molar mass times gas constant times temperature, all of it divided by pressure. 736 grams divided by 127.9 multiplied by 0.08206 times 648.15, all of it divided by 0.139 atms, gives us a total of 2,200 liters. Don't forget to use your significant figures when answering these questions. This time, let's take a look at the density problem. Calculate the density of a gas at 787 torr and 36 degrees Celsius if 3.2 moles weighs 8.899 grams. Now, because this is the density problems, remember that we want to find out grams per liters. The problem is already giving us the number of grams, 8.899 grams. Therefore, we must find the volume in liters so we can divide the number of grams by the liters and find the density of this gas. So rearrange the ideal gas equation. Note that you don't use the grams volume right away. the 3.2 moles times the 0.08206 gas constant times the 309.15 degrees Kelvin, all of it divided by 1.0487 atms, it gives us 77.4 liters. Now to find the density, we divide the 8.899 grams by 77.4 liters to give us a total of 0.115 grams per liter, which is the density of our gas. So if you have any questions regarding mass, molar mass, or gas density, please let me know and I'll help you out.